Okay, today we're going to look at non-permissible values. So first of all, we got to figure out why we're doing this. Our unit is on rational expressions, and the key thing to understand is a rational expression is a fraction of polynomials. So that means we get fractions like regular fractions, we get fractions that have x's, x squareds, and so on. But since we have a fraction, we can never divide by 0. So the denominator of our fraction can never equal 0. So if our denominator happens to be a rational number, or a variable, so we have an x instead of just a regular number, we have to make sure that we specify that what that x can't be equal to. So remember, variables can stand for anything. So in this case, 5 divided by x can be any number, but we can't have a 0 on the bottom, otherwise that fraction doesn't work. So if you have a variable by itself like that on the bottom, we just say our non-permissible value is x can't equal 0. So there's a restriction to this fraction. X can be anything except for 0, otherwise that would make it impossible to solve. If we had a fraction the other way around, right, our denominator now is 5, it doesn't matter. That'll never be 0, so then we just say there are no non-permissibles in this case, right? So because it's a 5, it's okay to do it that way. And what happens if we have more than one x? If we have x squared, so if you have an x squared or x cubed or something like that, it doesn't make any difference how many there are, because it would just be 0 again, because if x is 0, 0 squared is still 0. Okay, and if we have a number like 2x in front, and let's just leave it as x to the 1, we don't need to have it as x squared. So if we have 2x, our non-permissible is still going to be 0, because 2 times 0 is still 0. So having a number in front doesn't make any difference. We'd still say x can't equal 0. Okay, the types of questions that we're going to get to where they're not going to be equal to 0 is when you have a plus or a minus on the bottom. So if I give you something like this, 5 over x plus 2, so now what we're trying to do is we're trying to figure out what is going to make x plus 2 equal to 0. So all we'd have to do is subtract 2 on both sides. So x would equal negative 2. So in that case, negative 2 would make that whole thing equal to 0. So our non-permissible value will be x can't equal negative 2. Okay, so if I give you another one, if I gave you x plus 5, we could do the math the same way, but the simplest way is just do the opposite. X can't equal negative 5. If the number was a minus sign, let's do a different answer this time. So if we have x minus 4 on the bottom, the opposite of minus 4 would be plus 4. So those are pretty easy. And the only type you got to be careful of is if the bottom has two numbers. So if I gave you 2x plus 1, something like that, let's go back to doing it this way. What we're trying to do is we're trying to figure out what's going to make that equal to 0. So the first step would be do the opposite. So you'd have minus 1, but then we'd have to divide by 2. So our x would equal negative a half. So when you do those kind of ones, you do the opposite. So opposite of 1 is negative 1, but then you got to remember to divide by that front number, divide by that 2. And you can see with the old questions, we're really doing the exact same thing, right? There's actually a 1 in front of that x, so what we're really doing is opposite 4 divided by 1, but dividing by 1 doesn't do anything, so we don't have to worry about it. But if there is that number in front, you have to remember to divide it as well. Okay, so what we're going to be looking at today is how do we do non-permissible values in general. So when you get a question, typically what you're going to have to do first is what we did yesterday. You're going to have to do some factoring or some greatest common factoring or some square rooting to be able to figure out the non-permissible values. So if I give you a question that was 3 over x squared minus 9, okay, so what you want to do is look for a greatest common factor first, like we did. Then you want to do square root factoring second. And then the last step is figure out your non-permissible values. Okay, so for this first one, we don't care about the top. We don't have to worry about the top. We just want to worry about the denominator. So when you look at the bottom, can we factor it? Yes, we can't greatest common factor, but we could square root both sides. So when you square root the x, and the 9, so we'll have x plus 3 and x minus 3. So that's our first step, and then our second step, or last step, is figure out the non-permissible values. So now we have two things on the bottom, so that just means we're going to get two non-permissibles. So the opposite of plus 3 would be negative 3, the opposite of the negative 3 will be positive 3. Okay, so that's it. So you want to do factoring first, and then check for non-permissibles. So let's do another one. Okay, so let's suppose that was our question. Same thing, can you take out a greatest common factor on the bottom? The answer is yes. You can divide out a 3. So that'll give you x plus 2. There's no square rooting to do, so we know we're done. So now we just look at our non-permissibles. We have a 3. Remember, a number by itself doesn't do anything. We don't have to worry about that. We have x plus 2. So we just got to make sure we don't have a negative 2. Okay, so that's it for that one. Let's do one more. You can see in any of these cases the top really doesn't matter. Oops, I messed up on the last one. We had an x on the top. But you can see all the way through the question, the top just stays the same. We just basically ignore the top. We're only worrying about the bottom. So let's do... actually, let's change that. Let's do this to be 4x, something like that. Okay, so once again, can you do a greatest common factor on the bottom? Sure. We can take out a 4 and an x. So that would give us... Oops, I'm going to change it again, otherwise that's not going to work. Let's make that a 16. We can still take out a 4x, so then we'd have x squared. 16 divided by 4x would be 4. So that part's good. So now we did the greatest common factoring. Now we can still do a square root factoring. So you want to square root both of those. So we'd have 6x on the top, 4x on the bottom, and then we'd have x plus 2 and x minus 2. So we're good. So now we just got to take care of the non-permissible values. So we have an x out front by itself, or 4 times x, but it doesn't matter. That's still going to be 0. Then we have the opposite there, so minus 2, and the opposite for the last one is plus 2. Okay, so in this case we get 3 different non-permissible values. And that's it. So any of these kind of questions, you want to do factoring first, greatest common factoring or square root factoring, whichever are possible, or both, and then you want to do your non-permissibles after that. So you can always have 1 non-permissible value, 2 non-permissible values, or it could be 3 like we did in this example. Let's do one more that's a little bit harder. So let's suppose I get, let's do 16x squared minus 25. Okay, so we can't common factor it. We can do square rooting. So we'd have 4x plus 5 and 4x minus 5 as our 2 factors. So now remember, when we're doing these ones, you got to be careful of that 4 in front. So our non-permissibles will be the opposite. So negative 5 divided by the 4, and then for the second one, positive 5 divided by 4. And that's it. We'll stop there, and we'll continue with this stuff more later on.